Okay, question number 6. We're asked to find the modulus and the argument of z. So we've got z is minus 8 root 3I. So the magnitude of z, we're going to use Pythagoras. So it's 8 squared plus 8 squared times 3. And then we're going to square root it. So we've got 8 squared, we've got 1 squared and 3. 1 and 3, so we've got times 4. Could do this on a calculator clearly. So it's 16. Okay, so that, and the argument, I always find a little sketch helps, so I know it's minus 8 and it's plus, so it's up here somewhere, so I know the angle is going to be obtuse. So I do tan to the minus 1, imaginary over real, 8 root 3 over minus 8, which is tan to the minus 1 of minus root 3. And because I know where it is over here, I know the answer is 2 pi by 3. Okay, so now I found z. Now I've got to use Dewey's theorem to find z cubed. So I've got z equals r cos 2 pi by 3 plus I sine 2 pi by 3, and I'm going to raise that all to the power 3. So I get 16 cubed times cos 2 pi, because I multiply by 3, I sine 2 pi. Cos 2 pi is 1, sine 2 pi is 0, so I end up with 16 cubed, or 4096. Now find the values of w, so w is the 4, so I want the fourth root of z. So again I've got w equals the fourth root of z, or z to the power quarter. So that equals 16. Now because I want all the roots, I'm going to have to write it as cos 2 pi by 3 plus 2k pi plus I sine 2 pi by 3 plus 2k pi. Okay, so that is my z. Purely because if I add multiples of 2 pi, I don't change the value of cosine, and similarly the sine. Okay, so now I want to bring that to the quarter. So z to the quarter is fourth root of 16 is 2. And now I'm going to do cos of 2 pi by 12 plus 2k pi by 4 and plus I sine 2 pi by 12, because I'm dividing by 4, or multiply by a quarter, 2k pi by 4. Equals, simplify a little bit, 2 cos pi by 6 plus k pi by 2. Same angle both times. Okay, now I've just got to put different values of k in. Well, always start with k as 0 because it's easiest. So I get 2 cos pi by 6 I sine pi by 6, which equals root 3 plus I. I put k as 1 in. I get 2 cos, add a pi by 2 onto there. So it's 4 pi by 6 plus I sine 4 pi by 6, which equals minus 1 plus root 3i. Rather than 2 pi by 3, I've left it as 4 pi by 6, just because now I can see the pattern. So the next one is going up by, obviously, 3 pi's at the top. Or 3 pi by 6, which is obviously pi by 2. 7 pi by 6. Minus root 3 minus I, and k equals 4. I get 2 cos 11 pi by 6 I sine 11 pi by 6, which equals 1 minus root 3i. Okay, so I've done 4 consecutive values of k. I could have gone k as minus 1, minus 2, and I would have generated the same 4. Just going back the other way. If you really weren't sure, you could do a very quick sketch. Bad drawing of us. Okay, so we know that if we make that 1, and that'll be root 2. Root 3, 1.7. 1, it's 1, 1. If I plot the points on, root 3 plus I, minus 1 plus root 3, minus root 3, minus 1, and finally 1 minus root 3. So they should all be evenly spaced around on a circle and all have the same radius.